Okay, so now this is okay. Start recording. First of all, please look into this. This is the distribution of salary. Let's say my salary, your salary, someone's salary. This is a distribution of the salary. This is the all these are all 12 months, and this is the salary in each month. It is not uniform, it is variable based on some components, so some bonuses and other things. So this is the monthly salary. Now if I so you can say this is probability distribution or PDF function. This is a cumulative probability distribution. This is cumulative. Now, what is the meaning of this? I can show you through graph, then you can understand. So let me plot this graph and okay, this is very simple. Okay, you can easily understand if somebody asks you based on this monthly salary distribution, what is your salary in June? You can clearly say 12,000. What is your salary in March? 10,000. What is your salary in November? 10,000. So it's very easy to answer the question if somebody asks you, this is the salary. Now, if somebody asks you, what is the salary before March? Before March, not asking March, then you have to add January and February together, which is 10,000 plus 11,000, which is 21,000. And you can answer this because only 2 months. But somebody asks you, what is your salary before June? Then you have to add January to May and you have to give the answer. If somebody asks you, what is the salary after June? After June, that you have to include July to December and then you have to answer. So this is just challenging because it has 5-6 steps, 5-6 values to add together and answer. Therefore, for that purpose, cumulative distribution function is answer. So let me go and plot this cumulative one. So look into this. And now I put the level. And now, hope you can see it clearly. Let me make it bigger. So now if I ask, what is your salary after June? Then how will you answer? The total salary is 128,000. What is the salary up to July? Sorry, June is 68,000. 128,000 minus 68,000. Then rest of the value is your salary after June. That means 60,000. So in order to do sum of each month, you can just, you have the complete value, you have the total annual salary minus up to June, and then you get what is your salary up to June, and you directly point here and you get, okay, you don't need to add all previous 5 months. You can directly say 68,000. What is the salary of, so basically, such kind of question is explained using cumulative function. So this is the importance of cumulative function. This is the simple function. So there are two. If you want to know the exact value of exact month or exact value of exact x value, exact probability of exact x value, you use the PDF, and you want to do, plus in compound event probability, then you use CDF. So this is the value of PDF and CDF. And so this is a salary distribution. Similarly, you can assume probability distribution of different probability like binomial, like Poisson, like hypergeometric. So it is clear what we are going to learn. Two other concepts we are going to learn in this module. One is what is discrete and what is continuous. So hope you are in module 3rd, you know what is discrete and what is continuous. Any idea that you can share?
Discrete would be like an integer, continuous like decimal points.
Yeah, that's correct. Thank you. So like if I ask, there are as of now we have 16 people or 16 students, including me, in this class. So can I say there can be in my last class we have 15.5 or 15.4 students or 12? No, we can't say. So 12 months means 12 months. Similarly, we can't say there are like 80.4 car in the parking lot. No, only whole number, integer number are allowed. Those are discrete. But if I say my weight is 180.5 pound, okay, that's perfectly. My weight is my age is like this. So we can use decimal value in that. That is continuous. Discrete means whole or integer value. So chapter number 6 is only dealing with discrete values, and chapter number 7 is dealing with continuous values. So continuous probability distribution is based on any possible values, and here only integer values or discrete values. So this is the difference. Can I say, based on this chart, can I say what is the salary between June and July? What is the salary on 15th July? I can't say, I can't figure it out based on this probability distribution. But over there, we can find, the probability of 6.5 to 5.5 or something. So if this is clear to everyone, what is CDF, what is PDF, what is discrete, and what is continuous? These 4 concepts are clear to everyone?
I have a question.
Yeah.
What is the purpose of the cumulative?
What is the purpose of
Yes.
this probability?
No. What's the purpose of adding together all of the data points to get a cumulative distribution?
Okay.
Why is that important?
Okay. So basically, adding together cumulative, because you can answer quickly in just one, just in one step. So let's say, this is, you can do, if you want to do in simple way, what is the salary after June? Let's say in this case, after June, how will you answer that? You need to add all of the values after June, like July, August, September, October, to answer this question. What is the probability that after June or, after this event, next event will happen? So basically, this is the value, adding all the points together. But here in cumulative, you can do in one step. You can do in one step because total probability is 1, which is 128,000 here. So adding together, it can give you very simple answer in one step. So here, like, what is the salary after June? After June, July plus August plus September plus October plus November and December. Here you just whole salary is 128,000 and subtract up to 68,000, because this is just Up to June salary is 68,000. So 128,000 minus 68,000, which is 60,000. So you get direct answer. But if you want to do in multiple steps, most welcome, because that is also possible. You can add all probabilities of, and then you can do. So cumulative function is all increasing. So basically the value is keep increasing until it goes to 100% or 1. So adding in cumulative is actually a function, and it can give you the clear picture how it is increasing, and it can give you the answer of many questions that you have. So what is the salary before June? Before June, you can directly answer 56,000. Here you have to do multiple steps. So adding and defining cumulative is important in probability.
And so so this principle is gonna become more foundational for
Yes,
additional work that we're going to do in these chapters.
yes. So we are going to learn, we are going to learn with some real, in Minitab graphs. We are going to see all this, how it is applicable. So I'm just giving a simple definition of PDF and CDF function, how these are defined in chapter. This is the basic way to explain.
Gotcha. You're giving a definition. All right.
Okay, so let's go. First probability distribution is uniform probability distribution in chapter number 6. So what is uniform distribution? Every month you have exactly the same salary, and which is easiest, and it doesn't have much use, and we are not going to have any question related to that. But uniform distribution, when you have exactly same salary every month or throughout all events, the same probability. So the second probability distribution is binomial distribution. Let me start my, so uniform distribution, binomial distribution. What is binomial distribution? You have only two possibilities: yes, no, success, failure. One is something, second is opposite, is something against that. So basically binomial distribution is two exactly opposite situation. Let's say today we will have or today I will go for car repair, and probability is 50%. Today I will not go for car repair, and probability is 50%. So 50%. Today I will go to do my grocery shopping, 20%. Today I will not go for grocery shopping, which is 80%. So two situations, and which are opposite to each other, that case is considered binomial or Bernoulli experiment. So, or you can say 0, 1. So binomial distribution, success, failure, yes, no. Whenever you see this kind of situation, you use binomial distribution. Is it making sense? Whenever you see yes, no, or success, failure, 0, 1 kind of situation, you apply binomial distribution. Is it making sense? Because, first thing first, when you do the questions related to distribution, you need to identify which distribution is this question is referring. Means what distribution is asked in the question, or what information is given in the question, and what distribution it is asking. So first you need to identify distribution of the question. So binomial distribution characters are like this. So today, let's say I will go for walk. 20% probability, but since, you know, snow or chance of snow or something, I will not go for walk, 80%. If this situation is clear, we are going to see some practical example. So here, you know, this is you can see all the distribution, and this kind of slide explains binomial distribution, PDF, CDF, mean, how the mean is explained, how the standard deviation is explained, and skewed right or skewed left or symmetric. So this is the probability, these are the important items which are used in binomial distribution. N means number of trials, pi means probability of success. So these two are very important when you do so when you read the question, you need to find three items. So let me N, pi, and X. If you identify these three items in this probability distribution, you are perfectly fine. So first, you need to identify this is binomial or not. If you identify binomial, you identify these three things, and you can get the answer straightforward in just one click. Okay. Now I'm going to show you. So let's look into this question. What is the probability? Yeah, I'm going to show Heidi this in Minitab in a minute. What is the probability that exactly two of the next n equal to 12 cars serviced are late, and probability of service late is 10%. Car is not late, 1 minus pi, 90%. So basically, we don't need to do this. Let me show you how we can plug this number, these three things. We identify n equal to 12, pi equal to 10%, and x equal to 2. So let's look into this. Okay, this is Minitab. Can you see my Minitab?
Yeah.
Okay, under graphs, let me make little bit bigger. So okay, so here under graphs, this is probability distribution. You always use this option, last option, and do the OK. Here you have, can select any of the distribution. Binomial is this. So here you can see what is number of trials, which is n. N is given 12. Probability is 10%, which is 0.1. Now we need to find what is the value of x. So x value is, I think it is asking 2. And now I can just do this. Okay, I need to make it. Okay, here you can see. If you can see this, I'm just putting the value. So this is so first bar is about probability x equal to 0. The second bar is x equal to 1. The third bar is x equal to 2. And this is the answer which you need. Exactly on particular month, like I said, in June. What is your salary in June month? So here you can see x equal to 2. And you can see x equal to 2, probability is 23%. And now x equal to 3 is 0.08, which is about 8%. So the answer is, you can see because it is giving the numbers of all. So just put the pointer and see the value of X. Now I can do the same thing here. Sorry, here we have probability distribution. Can you see? And under this binomial, you can see the binomial distribution. And here you can see PDF, this probability. CDF is cumulative one. So we are going to use PDF because it is asking exactly on particular month or particular X value. Number of trials is 12. Event probability is 0.10. Input constant is 2. And now we get the answer. And this is the answer. If you can see my Minitab screen, 23%. Can you see this? So this is the second way of doing. Now look into the, so here, now I can show you the same thing in Excel. So I need to know the binomial distribution. So just equal sign. Binomial distribution, here you can see. And it is asking, see, you can clearly see numbers, trials, probability, and you can see cumulative or non-cumulative. So it's a 12 to 0.10, and for for PDF we put 0, for CDF we put 1. Oh, so binomial distribution. If I'm trials is 12 and probability is 0.1, and cumulative, or that we put 0 for, and you can see exactly the same number we are getting. Can you see? So here, same thing. Now fourth option through which we can do, and just a wait minute. Binomial distribution. Can you see my table? So this is the old age time, like Stone Age time, when I used to do these things by this reference table. So look into that. Probability, this is a probability, 0.01, 0.05, 10%, 15%, 20, and look into that. This is n equal to 2, 3, 4, 5. Since we are dealing with n equal to 12, so this is n equal to 12. And probability is 10. And x equal to 2. So this is x, n equal to 12, x equal to 2, and probability is 10. So you can see 2, 10, and you can see exactly the same value. Can you see my screen? This is highlighted number, same 23%. Now somebody asked, what is the importance of cumulative and this? So the combined value of all the event is 1 or 100%, which I'm going to show in a minute. So if you look into this is the for 0, for 1, for 2, and all together up to 12. Combined all is 1. So this is 23%, where this is the x equal to 2. Probability is 10%, and it's 12, and this is 23. So I explained this number using 3 methods. If you understand, now I am going to explain fourth way. So how can I see my Just a minute, I have to come up. One more way, and then so here you see, I'm just going to show you one more time. So this is event, and this is PDF. I'm just going to show PDF, I'm just going to show CDF. Now event is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if you see this, can make it little. Okay. Now, so these are the events. Now I'm going to do the probability distribution for this when n is 12 and probability is 10 and binomial. So I go under calculate probability distribution, binomial, and probability, and number of tries 12, probability is 10. Input column, and I have to put output column, and I have to put this is PDF. And now you see the values are right here, all the values. So what is the value for x equal to 2 is 23% right here.
I'm sorry, I'm in Minilab and I don't see those same menu options. So where you got this data? Could you go back to the menu?
Okay, so go under calculate, calculator.
Yeah.
Probability distribution, and I did binomial one.
Yeah,
And
I'm
now,
using the Minilab app online.
okay, the cloud version also has the same options, I believe.
It doesn't. The menu's totally different.
I had this problem today, I guess, and I actually had to go into the general apps virtual labs and search for Minitab. And then when I did it that way, it pulled up all the same options. But when I just clicked the link the first time, it didn't work. I had to go into, I typed in EW virtual labs.
So
I'm sorry, Kira, could you, this is Trisha Ely, could you send me a message with those instructions? Because I'm a little frustrated and that sounded like it would be helpful information.
Sure, yeah, I'll do that.
Thank you.
Okay, so what I was trying to say, okay. Let me recall what I was trying to explain. So this is a PDF and this is event. Let me run that CDF for the same thing. So instead of PDF, I put a CDF. Input column is same, and here output column would be CDF. And look into this. And here you can see this is total is getting 1, 1, maximum is total of all the probability. Sum is 1. 1 means 100%. Any probability, any answer will not exceed more than 1. So please remember, so this is a CDF value. And now we can check the same values. Here you can see, I think you can check side by side both values. So here this is a 10%, and you can see these 28, this is 28, 37, 37, 23, 23. So basically, now this is since outdated old age time. But if you want to do, if you want to do it easily, this is another option to use this table. But if it is asked more than or less than, then you have to add all of them, subtract all of them, or you have to do multi-stage or multi-steps process. But when it is cumulative or computer or Excel, you can do directly. So this is, so hope you understand how to get the probability. Now let me go for any question. So this is 23%. Now let me go for next question in the same. Yeah.
Professor, I got
Mhm.
a question. So
Please.
in Minitab, when you click into that binomial distribution window and there's an input constant, what is that? Can you repeat that? What value do we need to put in there?
Okay, so input constant is X value. So let me show you one more time. So here I go under calculate probability distribution. Basically, you know, I prefer from my side, I prefer to use this this method and see I can do binomial here. Number of trials are like 12 and event probability is 10%. And shaded area, and I can put X value is 2, and I can select either this one or that one, so I can get the complete distribution, and then I can select the right X value. If it is so, for example, I need to see X equal to 2. So this is X equal to 2 is this one, 23%. X equal to this much. So basically you can just place your cursor on the bar and you can get the value of, or you can get the probability value.
So
Other
what does
thing,
the red shaded and the blue shaded mean?
okay, so this is a compound event. I'm coming on that next step. This is compound event probability. What is the total? Like I said, after July or after June. So after June, so this is like, you know, this plus this total is 34%. So this is a compound, you know, even you can do the same thing before that, and you can see the answer here. And I just do this one, and you can see up to 2. So 0, 1, 2, this 3 together, this is 88 or 88.91%. So this gives you the compound event probability, red shaded area. But you know, when you put the cursor, it gives you the individual probability value. This
So in
total,
that case,
Mhm.
the 0.8891, that is the accumulate from the first 3 bars.
Yes, correct.
Got it,
So
thank you.
yeah, and you asked about in this. So here, so what is the important? N, pi, and x, 3 numbers. So here input column, since we are dealing, if you want to run the complete distribution, you use, otherwise you use the constant. And if this is cumulative, this is, so basically I'm doing, for example, cumulative, you will get like 88 or 89%. So here you can see, and this is like 88.9, the same value that we see here, 88 or 89, because we run cumulative one. That includes, so here, cumulative. Now let's go into the next step. So everyone is clear about what is PDF, CDF, binomial. Now we are going into the next complicated step, which is compound event probability. And let's learn about. So here, this is another example. On average, 20% of emergency room patients lack health insurance. So basically means 80% have the insurance, 20% doesn't have the insurance. So you can understand two probability, you know, yes, no, success, failure, 0, 1. So you can clearly understand this is binomial distribution case. In a random sample of 4 patients, What is the probability at least 2 will be insured? Now, this is a question, at least 2 will be uninsured. So pi is 20%, n is 4, and x is 2. Now we have to figure it out. What is at least, or what is the up to, and different three things. So let me show you the slide which is most important in compound event probability. This slide number 26. So whenever you solve any compound event probability, you just think about what is the question is demanding, and what is the x value, because here x value is very important. So at least 2. It is, for example, at least 2 means it includes 2, 3, 4, 5, 6, whatever is beyond that. So at least includes 2, 3, 4. Fewer than 2 means it is not asking 2. It is not asking 2. It is asking 0, 1. Fewer than 2 means not 2. Whatever below 2 will be in compound. Fewer than 2 or more than 2, if it is asking more than 2, means it is not asking 2. It is asking all above values of 2. So more than 2 means 3, 4, 5. So please understand what is the question. Now here, come here. At least 2 means it is asking 2, 3, and 4. Now, like, you asked me why we are using cumulative. Again, very simple. You have to do 3-step process. You do for 2, you do for 3, you do for 4, and you sum all of them. And this is 4, 5 steps process, or you can do in 1 step. So uninsured is 20%, n is 4, x equal to these numbers. So you can do for 2, you can do for 3, you can do for 4, sum all of them and you get the answer. Or you can do directly by, so I'm going to solve this problem. So this is the problem. Let's do in Minitab. In just 1 step, graph, probability distribution. I go directly here, and number of trials are 4. Probability is 20%. 20%. And now you can see the correct, like this is the right side values. So here, this is, I already put 2, and this is left side. If somebody is asking up to 2, then you can use this. Now we need more than 2. Sorry, at least 2. And now I use. And now you can get the direct answer, 18%. At least 2. So the total of this is 18%. Is it making sense? So 2, 3, and 4, whatever, or so 2 value is 15%. This is about 3%, and together is 18%. The same answer, 18%. So instead of doing separately for all 3 of them, you can directly do. Here, the same value you can do in this. I don't know how many of you are having this on your computer, but calculator, probability distribution, and binomial, and here cumulative, because this is asking at least more than. So number of trials are 4, 2.2. Input is, now very important question, challenge is here. You have to do here until 1, and you have to subtract from 1, because you can get total value is 1. If you do up to 1 and then subtract from 1, then you will get the answer. So here in this case, you will get 81.91, and 1 minus 81.91, which is about 18%. So you will get this answer in this way. Now let's do this in Excel. So I go and I do binomial distribution. So we are going to check up to 1. Tries are 4. Probability is 20%, 0.2. Cumulative, so we are putting 1 because we are checking this. And you can see this is up to 1 and we need 2, 3, 4. So what we need to do, we need to take 1 minus this value and we get the answer. So, but direct through graph, you can get direct answer. If you need at least lower part, left side, then you can directly get the answer. If you need up right side part, then you need to subtract from 1, which is 100%. Is it making sense? If you understand these few concepts, next steps are very easy for other distribution because this is the foundation.
So Professor, I understand when it says, or when the problem is clearly stated, it's equal to or more than or equal or, greater than or equal to all of those. But if a question is asking, so let's say if a probability of success is like 40%, but then what is the probability of us obtaining that first or second success within the first, 10 trials?
Okay, so okay, these are different, probability distribution. We are coming one by one on,
Okay.
each of them. So basically, this is the simplest yes, no. When you will get like you are running something like that, that is different distribution. We are following that in just,
Okay.
few minutes.
Okay, thank you.
Is everyone clear about what I'm trying to explain? Because I need to know your consent before moving forward. Everyone?
Yep, good with that.
Okay. So first is binomial, second is Poisson. How do you pronounce? I don't know, but Poisson distribution. And this is very important distribution in many cases. So basically this distribution deals with average. So whenever you see any situation of average, you can use this distribution. So binomial is yes, no, success, failure, 0, 1. Poisson distribution deals with average. So here, like, average arrival, average customer arriving in any credit union or any bank, 20 customer per hour, or flights arriving, 20 flights arriving in particular 1 hour in Spokane airport, or such kind of situation, you can use Poisson distribution. Therefore, you need only one item in this, which is lambda. So where lambda represent the mean number of events per unit of time or space. So when do we use? Whenever you see average mean number of events per unit of time or space. So lambda is important in this, and this is the distribution. Its a mean is lambda, its a standard deviation is the square root of lambda. So lambda and the square root of lambda. These two, you can automatically get average customer arriving in credit union, or average flights arriving, average flights departure, and then X value. What is the question demand? What is the X value? So, and then rest is X as it is. So like here in previous case, we looked into these 3 numbers. Here we need lambda and X. If this is clear, the same thing. So here you can see this question. on Thursday morning between 9 to 10 a.m. customer arriving in this credit union at the rate 1.7 customer per minute. Always remember unit of whatever unit is given in the question, the answer has to be given in the same unit. Let's say if this is given hours, like 17 customers arriving, or in our 60 minutes is there, so 100 customers are arriving per hour, and it is asking what is the probability 2 customer will arrive in next minute. Then you have to divide 100 customer by 60 to get the same minute arrival, and then you need to answer in the same. So basically always remember because I give some questions where it is in meters and centimeter, so different units. So first you need to convert these numbers in the same unit as it is demanding in the question. So here minute is given. So here you can see the X value. What is the probability less than or equal to 2 customer will arrive? So probability, what is the probability that 2 or less customer will arrive? That means it has to have all the previous value together. So let's do this in just a minute. So I go in graph, probability distribution, look into this, and now I need to select by Poisson. Mean is 1.7. So we need only mean, and we need X value, and this is left side. And you can see the total value is 75%. Direct answer, because it is adding 0, 1, 2, all 3 values together. So 75%, clearly you can see. So 75%. So what is the probability at least 3 customer will arrive? It is asking 3, 4, 5 and all. Then what you need to do? You need to get, so let's do this also. So graph, probability distribution, Poisson distribution, and the same value. And now we need this side, and 3 plus all other values, and you can see the value. And 3, 4, 5, 6, whatever is next is the total value is 24%. And what is the probability that exactly 2 customer will arrive? Then you can see this value, X equal to 2, and you can see 26%. So if it is asking PDF for exact value on particular month salary, then you need to put the cursor on the particular month bar, and you can get the value. If it is a compound, you can get through graph. So you can simply understand, or you can visualize the probability through Minitab easily. Now we are going to do the same example in this. So I just do Poisson distribution. And here it asking X value. X value is 2. Mean is 1.7. And cumulative, yes, we are doing a cumulative one. And you can see so the previous 75%, we need exactly the same value. So this is 75%. Now we can do the same thing in this, which is called Poisson distribution table. And you can see these tables at the end of your book. Now you see the lambda equal to, now we have to see lambda equal to 1.7 and X equal to, so basically you need to add this value plus this value plus this value. All 3 value together will be about 73%, 74%, whatever. So this is Poisson distribution. here you are going to add all three. Yeah. So I'm going to explain. So the same value. Now again, Minitab. So here you go under graph. Here you go under probability distribution. Now you please check this. Poisson distribution. What is important item in Poisson? Which is average, mean, which is, so I put 1.7. Now you need to decide what is the X value. X value is asking up to 2. So basically it covers in red area up to 2 because you need to see right side, you need to see left side, up to 2. Up to 2 means left side. So here it is, and up to 2, and you can see, and here you get the value up to 2, which is about 75%. Is it making sense, you? Okay, so this is Poisson distribution. Again, how do you identify which is Poisson distribution? How do you know, if you see average, so it is clear what is binomial, what is. Now we come to the third stage, which is called Poisson distribution, hypergeometric distribution. Very important here. Hypergeometric distribution can be used when finite population. When n value, capital N value is given. So basically here what you get in this, these three things you get. Capital N, which is population, small n, which is sample size, S is success, number of success in the population. This is a standard deviation, this is a mean. Another important thing, so this is the, it can be also approximated by binomial when pi equal to S upon n, and small n upon capital N is less than 5%. So please, this is very important case. So how do you get pi equal to S upon? First, you need to check what is this. Let's say you are doing, you have 20 samples out of 1,000. What you need to do? So n upon n should be, so this is, you can replace, you can use the binomial distribution in place of hypergeometric if you fulfill this situation. So how do you identify when you have capital N, small n, and you can see clearly this case. In a shipment of 10 iPods, 2 were damaged and 8 are good. So capital N is 10, which is total population size. Small n, so the Best Buy test a sample of 3 iPods. So small n is 3, 2 are damaged, S is equal to 2. Now it is asking what is the probability of different situations. So look into that. Capital N is given, small n is given, S is given. Now, based on the question, you can identify the answer. So here, so X equal to 0, X equal to 1, X equal to 2, you can use. Now, how do we put these numbers in Minitab? So I'm just going to demonstrate. Graph, probability distribution, and view probability distribution. Here you can use the hypergeometric. Population size is 10. 2 events are counted, 2 are defected, sample size is 3. And now shaded area, you can use because you can get the same value. So you can see this is n equal to 10, m equal to 2, n equal to 3, x equal to 0. It's a 46%, 46%, and the third is about 6%. The same answer you can get here, 6%, 46, 46. But whatever question based on x, you can find the answer. So this is hypergeometric distribution. Few question in fill in the blanks, you need to see this condition, n upon n should be less than equal to 0.05. So please remember, check this. If sample divided by population is this value, okay, go ahead and use the binomial distribution instead of hypergeometric. So now we go to the next one, like you are asking. So here, this is n upon n. This is a thumb rule of thumb. Please follow this. Now we have a geometric distribution. And somebody is asking, I don't know the name, I just hear the voice. The geometric distribution describes the number of Bernoulli trials until the first success is there. So like you are asking the same question. Let's say you are running some donation, when the first donation will come. So let's look into this university situation. 15% alumni make donation or pledge during the annual telefund or alumni meet or something. What is the probability that first donation will come on 7th call or 7th person? So this, when you see this kind of situation, when you see the binomial thing, 15% alumni make a donation, 85 don't make the donation. What is the probability when the first call will come on 7? So this is a geometric distribution case. So you need to identify different distribution before running it. So in this case, you can use geometric distribution. And here, what is 15%, and you can use this. So we can do this. Minitab and graph and probability distribution and geometric, hypergeometric, where is geometric? Event probability is 15%. Okay. So since 2 is already there, so 3, 4, 5, where is x? 6, which is about, you can get the value of each. So this is about 5%, 5-6%. So here you can see this is the same value, 0.0566. So here you can see where is 7th. Here you can see 0.056. The same value you are getting here in geometric distribution. Is it clear? So I think this is all about chapter number 6.
I'm gonna ask a silly question.
Yeah, go ahead.
There are like 3 sections or so in chapter 6, a mark optional, and I saw on your slides, it's also mark optional for the geometric slide as well. Is that something that you're gonna be test us in those optional sections?
So basically, my focus, this is a little advanced, in exam, my focus is about binomial and Poisson most. I go, little bit hypergeometric, but binomial, Poisson, these are the 2 focus point. Uniform, I don't, because uniform is simple and it doesn't have much value, because in practical life, we don't get a really uniform distribution in that everything is same. So Poisson and binomial is same, but it's important to know, like you asked, so I explained here. So these are the 4 distribution, important 4 distribution here related to chapter 6. Now, do you have energy to go for next 1 hour in chapter 7 related to chapter 7? Or you want me to hold another meeting on Thursday related to chapter 7?
If you could do Thursday for chapter 7, that would help me to get caught up on 6.
Yes, and same here.
Okay, I don't want to give you too much
Overload
at the
if
same
you
time.
do.
Yeah. Okay,
Yeah,
that's
Thursday
fine.
will work great.
Yeah, so you just practice chapter 6. Just do all, first, again, I'm telling, first identify which distribution is this question is demanding, or which distribution in information is given, and then asking the important values, like for binomial, pi, n, and x, for Poisson, lambda and x, for then asking whether it is compound and it is or non-compound, or maybe CDF or PDF, and then running and identifying, because X value, always people do the mistake related to X value here. So look into this. I'm just going to emphasize something where most of the people, at least 2. So where, less, for example, less than 2, somebody asks less than 2, then they use the X value up to 2. They don't use X value 1. If asking less than, then you need to go previous value. So here X value is 1. Okay. So please remember, this slide is most important for exam also, because you will get confused related to this situation. So always take a printout and put in front of you before solving any question. This slide, okay? Thank you and have wonderful evening. Yeah.
I have one more question. Is there an Excel function for the geometric distribution?
100%.
I couldn't see it in the book.
Okay, just a minute. Let me see. Hmm. I didn't do, okay, gamma distribution, gamma is there, geometric. I can't see. But I will, just give me, just send me an email. I will look, because I don't see here and I haven't. No, I don't see it is coming here. So I will research it and I will let you know.
Okay,
You
thank you.
just send me an email so I will remember that.
Got it. Thanks.
Most welcome. Any other question for tonight? If no, then have a good night and see you on Thursday.
The same time Thursday at 6?
Yeah, 6:10.
6:10. Okay, thank you.
Okay, bye.
Thank
Thank
you.
you.
Thank
Good
you.
night.
Thank you.
Bye.